Welcome to Conic sections, ellipses. In this tutorial, we're going to look at the definition of an ellipse. We will be looking at the ellipse placed in the XY axis system. We're going to be looking at equations of ellipses within the XY axis system and see how to deal with specific problems. An ellipse is made when a plane intercepts a cone. Of course, there's other shapes that are made, but we're going to specifically be looking at the ellipse today. If you were to take two pins from your house and tie a string to each of the pins, put those pins in the wall and pull the string tight with a pencil, then as you pull the string tight with the pencil and move your way around the two pins, the shape that you would make would come out to be an elliptical pattern. Let's look at the definition. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points, f1 and f2, is constant. The sum of those two distances, that was the string that we just dealt with. Those 2 points, f1 and f2, are known as the foci, or the focus points. Ellipses have a major axis, which is the longer, and a minor axis, which is the shorter. And the intersection of those two axes is the center. The ends of the major axis are known as the vertex points, or the vertices. We can come up with the equation of an ellipse placed within the XY system with the major axis along the x-axis. We can come up with an equation for an ellipse by showing that d1 plus d2 is equal to 2 times a. So let me explain what that means here. The sum of these two distances, d1 and d2, the string, is equal to 2 times a. And a is the distance from the very center all the way out to one vertex point. So d1 plus d2, that string, is equal to 2 times a. So that's like saying the major axis, right? If we identify some points on the ellipse and use the distance formula for d1 and d2 and simplify, we're going to eventually come up with the equation of the ellipse centered at the origin, with the horizontal axis being the major axis along that x-axis. We're going to be dealing with two equations right now. One with the major axis at the x-axis and the other with the major axis along the y-axis. Essentially, if your bigger value is underneath x, then your major axis is along the x-axis. If your bigger value is underneath the y, then you're going to be dealing with the major axis along the y-axis. So the b value represents the distance from the center to the end of the minor axis. There's a Pythagorean relation that says that a squared is equal to b squared plus c squared. So what that means is if we have an endpoint on a major axis and an endpoint on a minor axis, we can figure out where the focus points are. So once again, this is our major axis, which is the a value, and this is our minor axis, which corresponds to the b value, and the c represents the location of the focus points. We want to find the vertices, foci, and graph this particular ellipse. First of all, we have to put this in the form of an ellipse. And As you recall from the previous page, we have a 1 right there. And so what I want to do is I want to get a 1 in the place of this 36. So I'm going to divide everything by 36. And what that does for me is that gives me x squared over 9 plus y squared over 4 equals 1. The 9 is larger than the 4, which means that the major axis is going to lie along the x-axis. The minor axis will lie along the y-axis. A squared is equal to 9, which means that A is going to be at plus and minus 3. That will tell us that the endpoints, the vertices, and we know that B squared is equal to 4, and that means that B is equal to plus and minus 2. That tells us the endpoints of the minor axis. Let's go ahead and plot these points and look at the graph. So based off the A and B values, I have plotted the vertices and the endpoints of the minor axis. That gives the graph. Now we just need to find the foci. And we have to use the fact that A squared is equal to B squared plus C squared. This means that C squared is equal to A squared minus B squared. Let's plug in A squared and B squared to solve for C squared, which gives us the C values, which gives us the focus points. Solving for C gives us plus and minus the square root of 5, which give us the focus points on the graph. The square root of 5 is approximately 2.2. We want to find an equation of the ellipse with foci 0, -3, and 0, 3, whose minor axis has a length 4. Sketch the ellipse and support your sketch with a graphing calculator. Let's go ahead and graph what we have so far and figure out what we actually have as far as what the graph tells us. So here we have our points drawn, and this tells us a lot here. We know that the minor axis gives us the B value. So this distance here gives us a B value that's equal to 2, which means that B squared is equal to a 4. We also know the C value. This distance here is 3, which means that C squared is equal to a 9. Because we have B squared and C squared, we can figure out A squared. A squared equals B squared plus C squared, which means that A squared is equal to 13 when we substitute in B squared and C squared. This tells us where the endpoints of the major axis are located. This tells us the vertices. Our vertices are located at 0, plus and minus the square root of 13, which is approximately 3.6. One thing I forgot to mention is that the focus point and the vertices are located along the same axis. They are both on the major axis. Let's finish up our problem by making the graph. We also need to come up with the equation of the ellipse, which I have shown here. Y squared is over the A squared value because the y-axis is the major axis and the x squared is over the b squared value because the minor axis is the x-axis. So that's the equation of our ellipse. We also need to support the sketch with a graphing calculator, which means we need to solve for y. So I've solved for y down here at the bottom, and what that means is we need to plug in two different y equals into the calculator, one for plus and one for minus. Let's see what happens when we enter this in the calculator. Let's check our work, make sure we're right. So I've entered in y1, y2, and we hit graph, and that gives us the equation of our ellipse. And unfortunately it doesn't connect there, but we can see that what we found pretty much matches up what our drawing looks like. We're also going to be looking at ellipses with a center other than 0, 0, a center of hk. The h corresponds to the x term, the k corresponds to the y term. And to represent the hk with the standard form equation of an ellipse, you add or subtract the h value onto the x, and you add or subtract the k value onto the y. The a value is still the distance from the center to the vertex point. The c value is still the distance from the center to the focus point. The b value is still the distance from the center to the end of the minor axis. So if we look around here at the focus and the vertex, and really they had the endpoint of the minor axis, we'd see that we need to have the center along with A, B, and C in order to identify those points. If the major axis is parallel to the x-axis, that means that the larger value, the a squared, will be underneath the x squared. If the major axis is parallel to the y-axis, that will mean that the a squared, the larger value, is underneath the y squared value, the y squared expression. Let's go ahead and start off with example 3. We want to find the standard form equation for the ellipse whose major axis has endpoints -2, -1, and 8, -1, and whose minor axis has length 8. Let's start off by plotting these points. These points represent the endpoints of the major axis. So that tells us a lot. That tells us that this goes from -2 all the way to +8. That tells us the major axis has a length of 10. And if we cut that major axis in half, that gives us what a is equal to. So we have that a is equal to 5. So a squared is 25. Let's jump over here to this minor axis. The minor axis has a length of 8. Well, if we cut that in half, that gives us 4, which gives us b squared equals 16. The only thing else that we need in order to figure out the standard form equation of the ellipse is the hk value. And we can find that by going in a distance of 5, which is half of 10, to the middle here. And that gives us hk, which is when x is 3, y is -1. That's our hk value. And that gives us the standard form equation of the ellipse. We have x minus 3. Remember, we take the opposite to the power 2 over a squared. I know that we have the x squared over the a squared because the major axis lies along, the major axis is parallel to the x-axis. And we have y plus 1 because the -1 represents the k value. We take the opposite, y plus 1 squared over b squared, which is 16, equals 1. All right, so if I wanted to draw this actual ellipse, I would need to go up a distance of 4, 1, 2, 3, 4, and down 4 from the center, and draw my ellipse here. If I wanted my c squared, if I wanted my focus points, which would be somewhere here and here, I would need to use the fact that a squared is equal to b squared plus c squared and solve for c in order to identify those points. Let's go ahead and do that for good practice, actually. So down there in blue, I've solved for c, and I've found that c is plus and minus 3. So if I want to find my focus points, I need to add 3 and subtract 3 onto my h value. So let's see what that looks like. The focus points, one of them is when I take 3 and I add 3. The other one is when I take 3 and subtract 3. So we have one point at 6, -1, and then we have another point at 0, -1. Let's look at those in a sec here. So you can see here that I put my 2 focus points in bold because I made an incorrect guess the previous time. Alright, let's go ahead and move to the next problem here. We want to find the center, vertices, and the foci of the ellipse. The center, that's easy, right? We can find the center simply by taking the opposites next to the x and the y values. So that means that we have a center at -2, +5. That's our center. And let's go ahead and find the vertices. But let's get a picture of the ellipse. I think that will help us understand the different points that we come up with. Okay, so I plotted the center of the ellipse, and I've also written that a squared is 49 and b squared is 9. That gives us a and b. Because the 49 is underneath the y squared, that means that the major axis runs parallel to the y-axis. And to find the major axis endpoints, I'm going to have to go up 7. I'm going to have to go down 7. That's pretty easy to figure out what those points are just by looking at them. However, formulaically, we would simply add and subtract 7 onto the 5 to find those endpoints, the vertices. So there we have our vertices, and we can figure out our focus points using the fact that a squared is equal to b squared plus c squared. Let's go ahead and find the focus point. To find the focus points, we need the c value. So I found that c gives us plus and minus the square root of 40. So I'm going to have to add the square root of 40 and subtract the square root of 40 onto the k value of the vertex. Okay, so what does that mean? 5 plus 40, 5 plus the square root of 40, and 5 minus the square root of 40. Well, square root of 40 is somewhere in between the square root of 36 and the square root of 49, so that means 6 point something. So we would go up 6 here, and we would go down 6 here, and that would give us our focus points. Alright, so let's end there for now.